Today we're going to talk about sample spaces and probability. Here at the top, you'll see the state standards that are listed and the success criteria. So to be successful in this lesson, you need to be able to list the possible outcomes in a sample space. You need to be able to find theoretical probability, and you need to be able to find experimental probability. Some of your vocab: a probability experiment is an action or a trial that has varying results. Outcomes: the possible results of a probability experiment are outcomes. Event: a collection of one or more outcomes is an event. A sample space: the set of all possible outcomes is called a sample space. The probability of an event is a measure of likelihood or chance that an event will occur. So the likelihood or chance that an event will occur, that's probability of an event. More vocab as we continue. Theoretical probability: when all outcomes are equally likely, the theoretical probability of an event can be found using the following. All right, so it's going to be the number of favorable outcomes divided by the total number of outcomes. So you can represent probability by P of A. Okay, so this is the probability of event A happening. So we would do the number of favorable outcomes divided by the total number of outcomes. Geometric probability: some probabilities are found by calculating a ratio of two lengths, areas, or volumes. Such probabilities are called geometric probabilities. This should make sense, especially if you just come from geometry and you know that you use lengths, areas, and volumes a lot in geometry, so that's why this is called geometric probabilities. An experimental probability is based on repeated trials of a probability experiment. And you can find that by number of successes divided by the number of trials. That's an experimental probability. And the last definition, law of large numbers: the experimental probability of an event approaches the theoretical probability as the number of trials increase. This is called the law of large numbers. So that means the more times that you do an experiment, like the more trials you do, the larger number of trials, the closer it's going to get to the theoretical probability. All right, so up here on the right, you can see it talks about the probability of an event. The probability of an event can range from 0, impossible, to 100%, which is 100% certain. But the probability is going to show up most of the time as a decimal or a percentage, which is going to fall between that 0 and 100%. Couple key ideas: the probability of a complement of an event. The probability of a complement of an event A is P of A equals 1 minus P of A. All right, so one way to think about a complement is if you know the sum of the probabilities of all outcomes in a sample space has to equal 1 or 100%. So that means you can find the complement by taking that 1 or 100% and subtracting what you know from event A. So this is called P of A bar, and this kind of represents the complement of an event. So the complement is 1 minus whatever the probability of A is. Example 1, finding a sample space. So this is the first thing we're going to look at. So it says you flip a coin and you roll a 6-sided die. How many possible outcomes are there in the sample space? All right, so for a coin, if you flip a coin, we know the sample space is going to have 2 results. It's going to be either heads or tails. All right, so that would be considered the sample space. And instead of parentheses, we really should put this in brackets. Let me see. since we're talking about a sample space, my brackets don't look too good, but hopefully you get the idea. All right, now we also need to know the sample space for rolling a 6-sided die. So if we have a 6-sided die, we know it has 1, 2, 3, 4, 5, and 6. All right, now if you want to, you can use a tree diagram to list all your possible outcomes. So let's say heads can go with 1 through 6, and tails can also go 1 through 6. All right, so if we let H represent heads and T represent tails, we can list all the possible outcomes as heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, tails 1, tails 2, 3, 4. So if you want to know how many different outcomes, or you want to find the sample space, there are 1, 2, 3, 4, 5, 6 times 2. There are 12 possible outcomes when you have a coin that you're going to flip and a 6-sided dice. So how many possible outcomes in the sample space? 12, and here we listed all 12. Example 2, finding a theoretical probability. A student taking a quiz randomly guesses the answers to 4 true-false questions. What is the probability of the student guessing exactly 2 correct answers? All right, so we need the word exactly, because if you just say 2 answers, it could be 2, 3, or 4 correct. So that would include 2 correct answers. So we want to make sure it's exactly 2 correct. So let's make a chart here to help us. So number of correct answers. All right, so we're doing 4 true false questions. So we could have 0 correct, we could have 1, 2, 3 correct, or 4 correct. All right, so now we know how many different things we're going to be looking at, and now we need to look at the outcome for each. All right, so you could choose a letter to represent correct or incorrect. I'm just going to use check marks for correct answers and X's for incorrect answers. So let's say if there's 0 number correct, that means 1, 2, 3, 4 answers are incorrect. All 4 answers are incorrect. All right, so number of correct. If they got 1 correct, here you see that there is 1 correct answer. How many different possible outcomes are there? All right, so we could have correct for the first question, and then the next 3 are wrong. We could have the second question is correct and the others are wrong. Or we could have the third question is correct, the others is wrong. Or we got the first 3 incorrect and the last one is correct. So that would be the options for 1 correct answer. All right, now let's look at the different combinations for exactly 2 correct answers. All right, so we could start with 2 incorrect and 2 correct. We could have an incorrect, a correct, an incorrect, and an correct answer. So all we did was move the correct over to the left one. So move this check mark over 1. Let's do that again. So let's say we have incorrect and 2 correct and incorrect. So what I did now is move this one over to the right one to put the 2 correct answers in the middle. Now we can move this arrow here, or this check mark, to the front. So we're going to get a correct, incorrect, and correct. We also could have a correct where it's in the, this is the same except moved to the front. So we're going to have correct, incorrect, correct, incorrect. And then we could have 2 correct and 2 incorrect. Now, is that all my possible outcomes for 2? All right, so try to do this a little bit systematically so it kind of helps. All right, so for 3 correct answers, we're going to have 1 incorrect and 3 correct. Then we can move this over 1, and then we'll have a check mark, an X, a check, and a check. And then I can move it over 1 more time. So I'm going to have a check, check, X, check. And then I can have check, 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 X. All right, so I think that's all the possible outcomes for 3 correct answers. And then to get all 4 correct, it's kind of like 0. For 4 incorrect, it would, now this time it would be 4 correct answers. All right, so we need to find out how many total outcomes there are. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if we did this correctly, that's the total number of outcomes. All right. All right, now what does the question ask? We want to know what is the probability of the student guessing exactly 2 correct answers. So number correct, exactly 2. So not 3, not 4. Okay, exactly 2. So this one has 2 correct solutions, and this one has 2 correct solutions as well. But the wording of the question is very specific. It says exactly 2. So it's going to be 1, 2, 3, 4, 5, 6. So it's going to be 6 out of 16. And that will reduce to 3 out of 8. So if you remember, it's the number of favorable outcomes, okay? Number of favorable outcomes by the total number of outcomes. And we can write that as the probability. So this is the probability of this event happening. All right, if we want to look at 3/8 as a percentage, which we often do, look at probabilities as a percentage, we just type in 3/8, and that gives it to us as a decimal. To change this to a percent, this would be moved over 2 decimal places. So 37.5%. So 37.5%. And for this question, what that's saying is a student takes a quiz and randomly guesses for 4 true-false questions. We want to know what the probability is guessing exactly 2 correct answers. So the probability of guessing exactly 2 correct answers is 37.5%.